See, if you check the question, what we are having, if y is okay, y into root of 1 is x square plus x into root of 1 minus x y square is 1, then what is mod x is less than or less than 1 and mod y is less than 1? We need to find dy by dx. So now let us see how to solve this problem. First of all, this is also comes under implicit function. Let me write it down. Y into root of 1 minus x square plus x into root of 1 minus y square is equals to 1. So what I will suggest you is, directly if you want to do, yes you can, or if you want to use the substitution means you can do. So let me teach you the both the methods. So let us take this as a what I can say, let us do with the method 1. What is method 1 here? I will suggest you for this substitution. Whenever if you see 1 minus x square inside the root, I will suggest you go with the sign or with the cos. So here let us consider x. What is x? X is equals to sine theta, and we are also having y, right? Let us take it as a sine alpha. Is that okay? So if you take it out, what it will be? We can write it as in place of y, what we can do? This is nothing but sine alpha times root of 1 minus sine square theta plus x is nothing but what? Sine theta times root of 1 minus y is what? Sine square of alpha is equals to 1. If you check properly, we have one formula. What is that? We know that cos square theta plus sine square theta will be always 1. So from this, I can conclude cos square theta will be what? 1 minus sine square theta. In the same formula, I will be applying here. This is nothing but sine alpha into what it will be, root of 1 minus sine square means what? This will be cos square theta plus this is sine theta times root of this is cos square alpha is equals to 1. So what we can say, we can actually cancel the square and the root, square and the root. What we will be getting here? This is sine alpha cos theta plus sine theta cos alpha is equals to 1. If you check this properly, we are having a formula. What is that? Sin A cos B plus cos A sin B. Let me write it down. If you have a formula, sine of A plus B, what is it? This is a sine A cos B plus cos A sin B. Is it okay? So I will be applying the same formula in our case as well. So if I apply, this is our A. Okay, let me change the color so that you can figure it out. So I will be taking this as a, this is a B. Then this is B, this is A. Same formula I will be applying here. So this is nothing but what? Sine of A plus B. A is alpha, B is theta is equals to 1. Is it okay? Yeah. So from this I can say alpha plus theta is equals to what? Sine inverse of 1 alone. If you check into the question, if x is equals to theta, from this I can conclude theta is equals to sine inverse of x. Similarly, y is equals to sine alpha means we can conclude alpha is equals to sine inverse of y. Is it okay? So I'll be applying the same formula. What is alpha? Alpha is nothing but sine inverse of y. So this is sine inverse of y theta. What is theta here? That is sine inverse of x. So this will be sine inverse of x is equals to sine inverse of 1. Is it okay? What is our main thing? They are asking us to find dy by dx. Is it okay? So what we will do? Differentiate this function with respect to the x on both the sides. What is sine inverse of x derivative? We already know. This will be 1 by root of 1 minus x square plus this will be 1 by root of 1 minus, yeah, so this is root of 1 minus what it is. Okay, this is actually first one I have written in this way. Fine, let it be. So we are doing for what? You can ask me, ma'am. Okay, I'll go accordingly. Here we are having a first term as a y, right? What is the y? Sine inverse of y derivative 1 by root of 1 minus y square. And what is the derivative of y? Which is nothing but dy by dx. I have written in the opposite manner. That is also correct. Let it be. What is sine inverse of x? Which is 1 by root of 1 minus x square. What is sine inverse of 1? Should I write it as 1 by root of 1 minus 1 square? No. Whenever, if you can't see any variable in the term, obviously it will come under a constant. We know that constant derivative will be 0. Is it okay? So from this, what we can conclude here? We can say that 1 by root of 1 minus y square into dy by dx value will be what? Minus 1 by root of 1 minus x square. Try to send the denominator to the right side, which means dy by dx must be equals to minus root of 1 minus y square by root of 1 minus x square. The same thing I can write it as dy by dx must be equals to minus of root of 1 minus y square by 1 minus x square. Actually, this is our final answer. Is it okay? If you feel like, ma'am, if we want to do with the normal method means, that is also fine. I'll help you with the second method as well. Is it okay? So let us take the second method. What is the question we are having? That is nothing but y into root of 1 minus x square plus x into root of 1 minus y square is equals to 1. If I apply directly, differentiate this function with respect to x means what we will be getting? First term derivative, which is y dash into this term as it is, plus y into root x derivative will be what? 1 by 2 root x into internal derivative, which will in or what sorry, internal derivative of inside will be what? 1 minus x square means minus x square is 2x. Is it okay? Plus x derivative will be 1 into second term as it is, and plus what is root x derivative? First term will be as it is, 1 by 2 root, which is 1 minus y square. What is y square derivative? Minus 2y, which is equals to 0. Is it okay? Yes. So after this, if you check this clearly, I can cancel 2 here as well as here. So what I will be getting here, we are having okay, fine, this is 2y into y dash should be there. See here we are having y dash into root of 1 minus x square plus minus, it should be not a plus minus, only one term should be there. Let me take in this way, minus of xy by root of 1 minus x square plus this is root of 1 minus y square, minus plus this is minus, so this is xy into root of 1 minus y square into y dash is equals to 0. Is it okay? So what I will do here is, let us take all the y terms to one side. Y dash, if I take a common, root of 1 minus x square minus xy by root of 1 minus y square must be equals to, if I send this to the other side, this is xy by root of 1 minus x square minus root of 1 minus y square. Is it okay? Yeah. So after this, what I can do, let us do the cross multiplication, LCM let us do. So this is in the form of root a into root b. So this is root of 1 minus x square into 1 minus y square minus xy by denominator will be root of 1 minus y square must be equals to, if I take an LCM, xy minus this will be root of 1 minus y square into 1 minus x square. Is it okay? And denominator will be what? Root of 1 minus x square. We want only y dash. So if I check y dash, this must be equals to what it will be? The xy minus root of 1 minus y square into 1 minus x square by sorry, root of 1 minus x square. If I send this term to the right side, which is nothing but 1 minus y square by, this is root of 1 minus x square into 1 minus y square. Sorry, just a second. Yeah. So minus what we will be having here, that is xy. Yes. So if you check this properly, y dash is equal. So take minus common from the numerator. What we will be getting? Root of 1 minus y square into 1 minus x square minus xy into, this term will be as it is, root of 1 minus y square by, if you check the denominator, which is root of 1 minus x square, and this will be what? Root of 1 minus x square into 1 minus y square. This will be xy. Is it okay? Yeah. So if you check this, these two terms are same, so that we can cancel. What we will be getting here? Y dash is equals to minus root of 1 minus y square by root of 1 minus x square. So this one actually I can write it as what? Minus root of 1 minus y square by 1 minus x square. This is our final answer. What I said, tell you, what I told you, if you follow the first method also you will be getting an answer. If you follow this direct method, second method also you will get it, you will get an answer. Is it okay? If you feel like still if you have any doubts, you just let me know. Okay, thank you.